Hi everyone, in this video we'll be solving the problem sequence of sequence which has been asked in a couple of companies, and this problem is a very good problem when it comes to solving problems which have to be discussed in the form of all possible ways. So let us quickly see what the problem statement says here. So basically here the problem statement says that we will be given two integers m and n. Okay, so we'll be given one integer m and we'll be given another integer n. So n is the number of elements in the subsequence. Okay, number of elements in the sequence that we are having. Okay, n is the number of elements in the sequence, right? And m is what? M is the maximum value that a sequence can have, right? M is the maximum value. Suppose there is a sequence of length 4, so m will be the maximum value beyond which the element will not go. Okay, any element of the sequence will not go. That is the value m here. Okay, now what we have been given here is we have been given that in this sequence there is a special property. The property is that the I plus 1th element, that is the next element of the sequence, is at least twice the previous element. Okay, so that is what the first point says, that suppose that if there is a previous element of the sequence, right? Now this next element, that is if this is the ith element, then the I plus 1th element will be what? It will be at least greater equal to twice the previous element. Okay, so suppose that in this case, suppose that if the previous element was 3, okay, then the next element would be greater equal to 6. Okay, that is one thing that we need to notice. And obviously the overall property holds that in this sequence that we are making, all the elements should be less than equal to m. Okay, the highest element will be less than or equal to m, right? Now it says that the sequence I is greater than 0. So basically any ith element will be greater than 0. So basically the sequence will start from positive number. Okay, and it says that any ith element would be less than m. So the sequence of I, that is the second last element would be less than m, and the last element can go till m. Okay, so if you will see this first example, so suppose that if m has been given to us as what? M has been given to us as 10 and n has been given to us as what? Let's say 4. So what we can say here is, suppose if m has been given as 10, so if there are four such elements, okay, so what can I do here? So I can say that suppose that m is equal to 10 and there are four elements, so that I require in my subsequence. So the highest element of the sequence can be what? The highest element of the sequence can be 10, and suppose we have to generate four such numbers, right? So what I can do is I can say that if m has been given as 10, so there are two scenarios that can happen, right? Suppose that n is equal to 4, so suppose I have to generate the fourth number or the last number. So what can I say? I can say that if I will take m is equal to 10 as the last number. Okay, if I take 10 as the last number, right, that is this particular given m as the last number, right, of that sequence, then what I can say is, then in that case the previous number would be what? The previous number would be at least half of it, right? Because it says that the previous number is half of the next number. So I can say that if I am taking the fourth number as 10, then the previous number would be what? The previous number would be at least half. So I can say that m will become what? 5, right? And then n will become what? 3, because now I have to check for the third number, because I have decided that the fourth number would be what, or the nth number would be what? 10. Otherwise I can say that suppose if I don't choose this, okay, if I don't choose this, m is equal to 10 for the fourth number, then I can say that I will reduce the m by 1. Okay, and then what I can say is that n will remain still as 4. So I'll say that, okay, if I don't choose 10 as the fourth number, then I will go decrease by 1. I will say that, okay, what if I want to consider m as 9 and n as 4? Basically for fourth number, let's say if I want to consider or not consider 9. So this is basically, you can see that in this case, in such kind of questions, you have to apply all possible ways here, right? Because if you will notice here, the thing is that the sequence can be 1 2 4 8. The sequence can be 1 2 4 9 as well. The sequence can be 1 2 4 10, and the sequence can be 1 2 5 10 also, right? So if you will see here, what will happen here is m becomes 10, okay, and m is given as 10, n is given as 4. So I assumed in the left call, I assumed that the m is equal to 10 is the fourth number. Okay, then in that case the previous number would be what? The previous number value, m, I will pass m as 5, because the previous number will be at least half or maybe less than that. Okay, and I will say that I will consider for the third number. Otherwise, if I take m is if I don't take m is equal to 10, then I will say that I will allow the maximum number as 9 only, and I have to still figure out for the fourth number. Okay, now in this case, when I will expand this, so now what will happen here is, suppose that if I consider m is equal to 5 as the third number. So now if I consider m is equal to 5 as the third number, right, then in that case the previous number would be at least half. So m by 2 would be what? 5 by 2 will be 2 only in terms of integer, and n will become 2, because now I need to consider for the second number, because I have already taken the third number. Then what I can say here is that otherwise, if I don't choose this given m as the third number, m as 5 as the third number, then I will say that I will subtract m by 1, m will become 4, and n will become what? N will become 3. This is the choice that I have. Or like in the left side also, if in the right side also, you will see, so either I can consider m is equal to 9 as the fourth number. If I consider it as the fourth number, then what will happen here? If I consider it as the fourth number, then after that I can say that for the previous number it will be at least half. So then it will become how much? It will become m is equal to nothing but what? 4. Okay, and n will become 3, because now I want to figure out the third number. Similarly, in this case, the right call that will be made here will be what? That if I still consider m as 9, and then what? N as 4, m as 8, and n as 4. Okay, so if I'm still figuring out the fourth number, then I will say that if I'm not taking 9 as the fourth number, then I will try to see that whether or not I take 8 as the fourth number or not. Okay, now you will see that what will happen here is, so far I have taken two elements. Now suppose that I take m is equal to 2 as the second number, because n is 2, right? So I take m is equal to 2 as the second number. So if I have taken 2, then m will become what? Then the previous number for that would be at least half of it. So m will become 1, m will reduce by 1. Okay, and n will become 1. Now from here also, if you will observe, suppose that if I take m is equal to 1 as what? M is equal to 1 as the previous as the 1th number, the first number. Okay, then what will happen here? Then m will become 1 by 2, that will be 0, and n will also decrease by 1, so n will become 0. And now here you can observe that now I have reached a base case that when n and m are becoming 0, then I can say that I have made a sequence, because you can see that like I have taken 1 here. Okay, let me erase this and write it again. So you can clearly see that what I have here is I've got 1 here, right? You can see I've got 1 here. Then I've got, I had 2, 5 and 10. So you can see that 1, 2, 5 and 10 is there, right? So that is what I took. That is why I've written here that, because I took m is equal to 10. Okay, then I took m is equal to 5, then I took m is equal to 2, then I took m is equal to 1. The moment my m and n both become 0, then I should return 1. That is, I have made one subsequence, like I have made one sequence, because you can see 1, 2, 5 and 10 is following the property that the current number is always at least twice or greater than twice of the previous number, because you can see 1 is like 2 is twice of 1, 5 is more than twice of 2, and then 10 is twice of 5. So that is why it is following the sequence, right? Now in this case I could have made another call as what? Another call that I could have made is that I consider m as 1 and n as 2. Now you can see there is a problem here. The problem is that when m value is 1 and n is 2, so m is 1 only and n is 2. If I require two numbers, right, and I if I require two numbers, so the moment it happens that n becomes greater than m, then I cannot make the sequence. Why? Because the number, like I need two more numbers in the sequence, okay, and I have got m as 1 only, so I cannot do so. Whenever n will become greater than m, okay, the number of elements required becomes greater than the m value, then I cannot make the subsequence, because you can see if I require two numbers here and I have m as 1 only, so then I cannot get the two numbers, because if I take m is equal to 1 as one of the numbers, then other number I cannot take, because 0 cannot be taken. So you can observe this condition that whenever n will become the number of elements that I still want, if it is greater than the m value, then I cannot make the subsequence. So this is basically a recursive approach in nature, and when you will run the for the whole diagram, right, when you will complete the whole diagram, then you will get four such sequences. Because you can see when I am doing the dry run of this first branch, that is the leftmost branch, then I'm getting the sequence 1, 2, 5 and 10, and whenever m and n both become 0, then I should return 1, that I am getting one sequence of the for the given condition. Okay, so this is how you have to do it. Now let me just summarize this. So basically you can say that if you are in a recursive function and you have got m as well as n, so you can say that what you can do is either you can take the mth like m as the nth number. Okay, so this is when you take m as the nth number. Okay, nth number, when you take m as the nth number, then the previous number, for the previous number you will call like you will say that you will consider m by 2, and the previous like you it will be n minus 1, because if you will see this case, so since you were considering 10th as the fourth number of the sequence, then now you had to figure out the third number, that is the n minus 1th number, and for that you will be allowed to have m as 5, that is half of it, because the previous number will be half or less than half, right? So that is why we will call for m by 2 comma n minus 1. Otherwise, if I don't take m as the nth number, then I will call for m minus 1. Okay, I'll try to consider m minus 1 as the nth number. Okay, so I'll call for m minus 1 comma n. This is the recursive relationship that we are able to draw here. Now let's try and code this up and see what we can do here. Okay, so I'll just increase the font quickly. Now what you have to do here is you can basically say that you can write a return recursive function here. Okay, and you can pass m comma n here, right? So here what I'm basically doing is I'm passing the m and the n. Now in this case I will have int recursion. You can name the function as anything that you want. Int m comma int n. Now what is the base condition? The base condition is that if suppose that the n value equal to 0 and at the same time m also equal to 0, so this means that we were able to make the subsequence of the given length with the constraint of m. Okay, then we will return 1, as you can see in the leftmost branch of my recursion tree that I have drawn. Okay, another condition is that suppose that if m becomes greater than if n becomes greater than m, so if the number of elements that are still required in the subsequence, if it is greater than the m value, the maximum value of the subsequence that I can have, then it is not possible for me to make the sequence, so then I will return 0. Okay, otherwise what are the two choices? So the choice one will be that I can call for what? I can call for recursion of m by 2. So I can take m as the nth number, and then I have to consider from m by 2, and now I'll figure out the n minus 1th number. Okay, otherwise the choice 2 is what? The choice 2 is that I can call the recursion and I can say that I will not consider m as the nth number. I'll try to call for m minus 1, and I'll say that still I'm figuring out the nth number. Okay, and then at the end of the day you will return what? You will return the sum of both the choices, right? Now because from both the choices you can get subsequences, right? Let's try and run it and see if it is working on the samples or not. Obviously it is a brute force code in nature, right? So you can see it is working on the samples, but when I'll submit it, it will give a TLE. Why it will give a TLE, I'll just let you know. Okay, so you can see that it is giving segmentation error, that is basically time limit exceeded error, right? Now why is it giving a TLE error? Because of the fact that it is exponential in nature. Right now the complexity of our code is what? Like it is exponential in nature, because there will be a lot of overlapping sub problems, right? So because what will happen is you will call same recursive functions again and again. Okay, so it will be like exponential in nature, or you can say 2 to the power n cross m. But what we can do is we can memorize it by using dp, and then it will become n into m, because every state will be calculated exactly once if we use the dp approach. Okay, so let me just quickly introduce dp here. So what I will do is since I know that in the given constraint m and n will be 100, so I can declare a dp of 101 size, okay, that is 101 into 101. Okay, and then what I can do is I can initialize my dp as -1. So I can initialize all the states initially as what? -1. Okay, so like I'll put right size of dp. Then after that, what we need to do is we just need to check this condition that if the dp of mn, it is not equal to -1. So if that state is already calculated, then we'll not calculate that state again. Okay, so we'll return dp of mn. Otherwise what we'll do is if it is not calculated, then we'll calculate that value. Okay, and then after that we'll store it in the dp so that we don't have to calculate it again. So we'll store dp of mn as this value that we have calculated, and then we will return this value. Okay, so that we don't have to calculate this particular state m comma n state again. Okay, let's try and run it, and it will obviously work on the samples, but we need to check whether it is working for the cases or not. Okay, now let's try and submit it as well. If there are any errors, we'll try to check. Okay, so still I have got an error, right? So basically my code's output is a lot compared to what is expected here. So let me just check what is the issue in my code. So I'm passing m and n. Okay, then I have initially made the dp also. Now it is expecting 10, but I'm giving 6. So the issue is that I'm passing m minus 1 comma m. if n is this thing. Okay, now maybe what I can check is, suppose if n and m are same, if n is greater than m, then we need to return 0. Okay, so is there any other condition that we should check here? Okay, let's figure out. Okay. So basically the thing is, yeah, I figured out the thing. The issue with my code is that it is not always necessary that m should become 0. Okay. So like basically you can say here that whenever, like it is not necessary that m should be equal to 0 and n should be equal to 0. It is not necessary. Why? For the first try, when we were giving it for the leftmost branch, we were having m and n both as 0, but that is not required. Okay, actually whenever n becomes 0, okay, whenever you have made all the elements, okay, whenever you have all, like n becomes 0 means what? All the elements of the of the sequence have been discovered. So when all the elements of the subsequence have been discovered, then only you can return 1. You don't need m is equal to 0 here. So if I will now run it, I think it should work fine. Let's check. Okay, you can see that it is clearly getting accepted. So yeah, this is the point. Like basically you don't want always m to be equal to 0. Okay, because it might be it might not be necessary that the sequence always starts from 1, right? So that is why you can say that whenever all the elements of the subsequence are made, then n of the sequence are made, then n value will become 0, and that is when you can stop. So I hope that you have understood this problem clearly. If you, in case if you have any doubts, so you can ask me in the comments. And thank you for watching this video. Keep coding, guys, and make sure to comment understood if you have completely understood this problem.